Let's talk about some data store concepts. First, you're going to have to know the difference between the different data stores themselves. One type is called persistent data store, and that just means the data is durable and it sticks around and it survives reboots or power cycles. Examples of this are Glacier and RDS. Then we have transient data stores, and that just means it's just passing through. The data is just temporarily stored, and generally speaking, it gets handed off to another process. And examples of this are SQS and SNS. Then we have ephemeral data store, and that means that the data does not stick around. So if you stop the instance, or in some cases reboot the service, the data is gone. Examples of this are EC2 Instance Store and Memcached, which is under the Elasticache portfolio. Now, another important piece is understanding the difference between IOPS and throughput. IOPS, input-output operations per second, really measures how fast we can read and write to a device. And you can kind of think of it as like a small, compact sports car that goes really fast. Throughput, on the other hand, is how much data we can move at one time. So think about it as this big, giant dump truck. So the dump truck can move more data than the fast car, but the fast car is going to get there faster with a smaller amount of data. Another concept you'll hear a lot about in terms of storage and databases on AWS is consistency. Simply put, it's a matter of keeping things in order. You can kind of think of it as a set of ground rules that a data store plays by so that we can be sure that when we hand it data, it's going to behave in certain ways. Now, there are different consistency models, and we're going to talk about two here. One's called acid and one's called base. Now, no, this isn't a discussion involving chemistry and pH levels. These are just acronyms for different characteristics of consistency models. Now, you probably dealt with the impact of acid models, mostly in relational databases. Relational database management systems have concepts like row locking and rollbacks, and that's how the database achieves ACID compliance. Now, these attributes are as follows. They're atomic, meaning that the transactions happen all or nothing. So a half transaction can't get written to the database. The transactions should be consistent. The transactions must be valid. They can't be corrupted. The transaction should be isolated, so when one transaction is happening, it shouldn't mess with another one trying to happen. And the transaction should be durable, meaning that once the transaction is committed to the database, then it should stick around. It shouldn't be at risk of just evaporating. In contrast, we have something called the base consistency model, and some of its attributes are it's basically available. So in other words, it values availability even if the data is stale. And we'll see examples of this in various AWS services. Another attribute is it has a soft state. So it may not be instantly consistent across data stores, but it is eventually consistent. So in other words, if it has multiple replicated data stores that it's trying to share its data with, maybe all those data stores aren't instantly updated with the latest version, but eventually it'll get there. Now, you might be saying to yourself, why in the world would I want an inconsistent data store? Well, as accurate and precise as ACID models are, they don't scale very well. And again, you've may seen hints of this with relational databases as well, when row locking or contention slows down the database when it's getting really hammered. This is the ACID model work because it wants everything to be perpetually consistent. But just scale that by several orders of magnitude, and you'll see why there's other approaches that need to be considered. Plus, base isn't inconsistent. It just accommodates things in a more parallel-friendly manner. So look for these attributes in the services of S3 and Dynamo.